Okay. All right, we got a square patio, and we've got patio stones that are 24 inches by 36 inches. So here's one patio stone, 24 inches by 36 inches. Is that a square? No. So you can't build a square patio with just one of them. If you took another one down and you wanted to try to make it a square, you would probably put it here because this side was shorter. But now when I add another 24 here, now it's 48 by 36, and it's not a square. Now the 36 side is shorter. So I'd probably add 2 more here. Is that a square now? If I add another 36 that way. Now the one side is, it's not to scale, it may look like a square. This side is 72 now, and this is 48. So if I added another one down here, yeah, this is very much not to scale, but that's a perfect square. Yeah. Because this now adds up to 72, and 3 of these add up to 72. From yesterday, what technique did we just use? The LCM. And we use the leapfrog technique, right? Because what we were looking for was the lowest common multiple. Because once we found the 72 to be the same, then we could figure it out. Now this one didn't take too much work to figure it out, but if I gave you tiles that were really funny shaped, then it might take a long time to draw it out, and then being able to start this way, say I gave you 15 and 19 as sides, it would take a lot of these drawing out to finally get there. But I hope that while drawing it out, you realize, hey, I'm doing the leapfrog technique. That's the lowest common multiple. And if the leapfrog technique in drawing this starts to seem like it's taking too long, then you could go to your prime factors. So for example, 15, if it was a 15 by 19, 15 is 3 by 5, 19 is 19. The least common multiple of those ones would be 3 times 5 times 19, which is, what's that, 285? So I think, might be off. That would take a long time to do the leapfrog way. I'm going to add another example to this one, a greatest common factor one. Oops. What is the smallest square tile, not the smallest, the largest. What is the largest square tile (75 centimeter by 250 centimeter rectangle? Assuming tiles cannot be cut. Because if you could cut a tile, then you would just start with your big 250 centimeter tile and plonk, plop it down, you'd be done. It would only take one tile and you'd cut it, it would be perfect. Okay? But now we're imagining we have 75 centimeters here and 250 centimeters here. It's quite long, I think, quite a bit more than 75. Again, not to scale. Can you see that 1 centimeter squares would fit? They would work. But they might not be the largest ones. But you could buy 1 centimeter square tiles and tile it. Can you see that 2 centimeter square ones will work along the 250, but won't work along the 75? 5s will work, right? You could go by 5s along the 250 and 5s along the 75. Now, is that the largest one? Okay, so what kind of question is this? Is this a least common multiple or a greatest common factor question? Greatest common factor. So if you recognize that, you might say, well, I know how to find the greatest common factor for 75. Well, that divides by 3, leaving 25, 5, maybe 5, 5, 1. And 250, well, that divides by 2. 125, that divides, does that divide by 3? No. Divides by 5. 25 divides by 5. 5 divides by 5, 1. So what's in common? 1 5 in common, which you said already, and another 5 in common. So the largest square would be a 5 by 5, or sorry, 25 by 25 centimeter square. And can you see that there would be 3 on the 75 side? And I don't know if that's enough. Is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it is. Yes. 10. So the square would be a 25 centimeter square on each side. And have I shown you the homework already? How do you do lowest common multiple for 3 things? Do the same thing. I think we can get it done in a minute. 28 would be 2, 14 would be 2, 7, 7, 1. 42, 2, 21, 3, 7, 7, 1. 63 would be 3. 21, 3, 7, 7, 1. So we've got 28 is 2 squared times 7, 42, 2 times 3 times 7, and 63 is 3 squared times 7. The least common multiple would be 2 squared, because you look at the highest power for 2's. What's the highest power for 3's? 3 squared and 1 7. So that'll be 4 times 63, 252? Awesome. Have a great night, guys.